Okay, so let us start. So today actually we will be starting with a new topic called calculus. Right, calculus. Now this topic actually, this is one of the very fundamental topic, and many of the other topics actually just depends on this particular topic, because a lot of concepts that were covered here which are actually very fundamental. So like actually, so in this actually we will be covering differentiation, integration, and limits and continuity, right, limits and continuity, and then actually the applications of all these concepts. So this is actually the syllabus actually. Now these topics, whatever we are going to discuss it here, so it will be applicable to many of the topics. To name of our topics, right? So if you take our mathematics optional topics, so we will just list down the topics. So one is actually the linear algebra, and the second one is the calculus, and third one is coordinate geometry, right? And the fourth one is ordinary differential equations. And the fifth one is statics and dynamics. And the sixth one is the vector analysis. And all these things actually forms paper 1. And coming to paper 2, we have actually paper 2. So this is the 7th one actually. So this is abstract algebra. And the 8th one is the real analysis. And the 9th one is complex analysis. Right, complex analysis. And then, so 10th one, linear programming. And 11th one, so this is partial differential equations. And 12th one, numerical methods. Analysis. And 13th one is mechanics and fluid dynamics. So these are all the total 13 topics actually we have it in our syllabus. And in this actually many of the topics just depend on calculus. Let me show you what are all the topics that will be dependent on this calculus. And so linear algebra actually is an independent topic. It is completely the matrix algebra, and a little bit of the abstract algebra is covered as vector spaces here. And then actually calculus is an independent topic, so which can be started straightforward with +2 level of knowledge. So this is actually +2 level of knowledge actually is sufficient enough to understand this calculus. There are no advanced concepts involved in it. In fact, actually 50% of the syllabus of calculus we have learned as part of our intermediate itself, right? So that is why actually that topic is very fundamental to start, and very easy also. And then actually coordinate geometry also is not dependent, it is independently can be started. And ordinary differential equations actually, so most of the times actually we went back and discussed the calculus while dealing the ordinary differential equations, if you notice, right? So we were doing the differentiation, we were doing the partial differentiation, and we were doing the integrations, we were doing the double integrations, all such kind of concepts actually we have discussed in the ordinary differential equations. But ideally it would have been covered in the calculus itself. So calculus actually is such a fundamental topic. And then actually statics and dynamics actually purely it is dependent on calculus, because we have actually the solution of the differential equations, and we will be doing the differentiation, all such kind of concepts again, which we will be using as part of this statics and dynamics. Especially in the dynamics actually we will be using that. And finding out the maximum value, minimum value, such kind of concepts we will discuss in calculus. The same thing actually will be applicable even in the statics and dynamics also, right? So this is actually a dependent. And the vector analysis is mostly dependent on the calculus, because the vector analysis, other name is the vector calculus. That means calculus plus vectors together is called as the vector analysis. So here actually to a greater extent we will be using the calculus. So this is one topic actually we rigorously use the calculus, and this is one topic actually we rigorously use the calculus, and this is actually to some extent actually we will be using, not to a greater extent, but the basic concepts we will be using it in this particular case. And then abstract algebra is completely an independent topic where there is no dependency of any of the other topics. So which you can straight away start with. So here actually, so this actually wherever I put a tick mark, that you can assume that that can be straight away started. So without having any prior knowledge. So even this one also it can be started, and abstract algebra actually can be started. And linear algebra actually certain portion is completely matrix theory which can be started independently, but there is certain portion like vector spaces. That concept is actually widely discussed in abstract algebra. So once you are done with this abstract algebra, if you go back to this linear algebra, then you will find it much more comfortable, right? So 50% is actually dependent on this. And then actually, so real analysis, actually you cannot separate the real analysis and the calculus. So these are actually together called as a single topic most of the times, calculus plus real analysis, because the real analysis actually the calculus applications to find out actually certain series and the sequences and their behaviors and how to identify such kind of characteristics. All those things actually we will be discussing as part of the real analysis. In that mostly actually the limits concepts are actually which are very widely used. So that's actually real analysis and calculus are actually you can consider as a single topic. And so the concepts are actually interrelated. Even the Rolle's theorem, Lagrange's mean value theorem, all those things actually what we study as part of the calculus are even be studied as part of the real analysis also. Improper integrals, right? Riemann integrability, all such kind of concepts actually we will discuss it here. So that means this is purely dependent on calculus, right? So mostly dependent on calculus. And then actually complex analysis, again actually it is dependent on the calculus. Why? Because we will be using the partial differentiation techniques and we will be finding out the limits, continuity, whatever the knowledge we acquired as part of calculus, the same thing is repeated again for the complex analysis, because the calculus can be otherwise be called as the real analysis also. So whatever the concepts we discussed there, that is the limits, continuity, differentiability and integrability, all such kind of concepts we will discuss in calculus. The same thing what we have discussed for the real numbers, exactly the same thing we will discuss even for the complex numbers, which is what we call as the complex analysis. That means there is a direct one-one correspondence between the calculus knowledge and the complex analysis knowledge. So one-one correspondence. So we find out the limits there, we will find out the limits also here. We'll find out the differentiability and integrability there, and here also differentiability and integrability we'll find out here as well. So that is the mean value theorem actually we are applying here, actually Cauchy's theorem, actually all such kind of concept, linear expansions, all those things actually we will be doing even here as well. So that's why there is a one-one correspondence and there is a huge interdependency with calculus even for this particular topic. And then actually, so linear programming is completely an independent topic which you can straight away start with, and no prior knowledge is required, and so none of the dependencies are there in that case. But this partial differential equations actually to a greater extent it is dependent on ordinary differential equations. So the concepts of a solution of the differential equations like linear differential equations actually we have solved, and the same concept actually we will be using there also. Even for finding out the particular integral we were using certain techniques here. The same concepts actually we will be even using in finding out the particular integrals for the partial differential equations. So here the partial differentiation is still mostly dependent on ordinary differential equations, and ordinary differential equations again dependent on the calculus. So it is again dependent, right? And numerical analysis actually that is purely dependent on calculus, because we will be using certain techniques like expansion, so Maclaurin series expansion and mean value theorem expansions actually we will be using in the numerical analysis. And those things actually we need to be understanding in the calculus itself so that you can easily understand in the numerical analysis. So we'll be using the numerical analysis for finding out the integrals, for finding out the differentiation, and for finding out the solution of the transcendental equations. So different techniques what we have discussed in the calculus will be reused there. So that means numerical analysis is purely dependent on the calculus again. Got it? And computer programming is actually part of this numerical analysis, that is anyway independent topic, no way dependent on any of the other topics. So if at all there is a dependency, that is on the calculus. If there is no dependency, it's not dependent on anything, right? And then actually, so mechanics and fluid dynamics, as you know that actually very, very complex level of knowledge we will be acquiring here itself. And this is dependent on many of the topics. So one is the partial differential equations, we need it. Vector calculus, you need it. Complex analysis, we need it. Calculus, we need it. So this actually is hugely dependent on many of the topics, not for this mechanics portion, in fact, only for this fluid dynamics portion. So fluid dynamics is such a complex subject, so which is dependent on many of these topics. So these topics like complex analysis, we will be using it. And so the other topic is what we are using is the calculus, we will be using it, and ordinary differential equations, we will be using it. And any other vector calculus is hugely dependent for this particular topic. Got it? So these are all the concepts. And mechanics is actually completely straight away you can start off, no dependency on any of the prior topics. This is simply a purely a physics subject which you can easily understand. Statics and dynamics is different, mechanics is completely different, though the terminology is same. Got it? So this is the importance, such an importance of this calculus topic. Got it? I hope you understood the importance of it. So if at all you wanted to take any order of preparation, you go with the calculus first, then you can start any topic. Got it? Understood? Any questions? Any questions on this? Now let us see what is the syllabus that is involved in this. So the syllabus is right. So I will be answering few questions. So one is actually what is the syllabus? And the second one is what are the books? And third one is right. And what is the weightage of this topic? What is the weightage of this book? And the fourth one is what are the important areas of focus? What is the important areas of focus? And the fifth one is approximate number of hours. For this topic. Right? So, and the sixth one is the previous year questions. So these things actually I'll be discussing it now, right? And if you wanted me to add any questions, you can let me know now, right? So these things actually I'll be covering it. Now coming to this particular topic actually, so the main thing is actually what is the weightage of this particular topic, and as usual, so this topic actually it carries directly 70 marks weightage, because 70 marks is a standard number for all the topics. Nowadays actually it is equally distributed for all the topics, so every topic is having the weightage of 70 except for the section A of paper 2. Section A of paper 2 will be having 4 topics. So all other sections, so section A, section B of paper 1 and section B of paper 2, each topic will carry a weightage of 70 marks. And section A of paper 1, paper 2 actually, it will be having the linear programming, abstract algebra, real analysis and complex analysis. Real analysis and complex analysis will share 70 marks each. And abstract algebra and linear programming together, it will cover 140 marks, right? So I think so. This is 70 plus 70, right? 70 plus 70. And then actually, so if these are 70 plus 70, 140, right? Remaining 60 marks actually it needs to be shared across. So sometimes actually what they do is actually they will give this for 60, this for 60, and remaining 80 marks actually it will be distributed between that linear programming and abstract algebra. So abstract algebra, it is generally given lesser weightage. So lesser weightage when compared to other topics, because linear programming includes in that to take the weightage. Got it? Other than that, as a standard rule, you can take every other topic is having a weightage of 70 marks. Got it? And then actually, what are the important, so all these things actually so automatically follows with the syllabus. So let me discuss the syllabus first and see what are the syllabus actually we are going to discuss in this. Let me write down. Right. So real numbers, functions of real variables, limits, continuity and differentiability. real numbers, functions of real variable, continuity and differentiability, continuity and differentiability, mean value theorems, Taylor's theorem and remainder, mean value theorems, Taylor's theorem, with remainders, Taylor's theorem with remainders, indeterminate forms, maxima and minima, asymptotes, curve tracing, indeterminate forms, maxima and minima, asymptotes, curve tracing, asymptotes, curve tracing, functions of 2 or 3 variables, functions of 2 or 3 variables. In the title, limits, continuity, partial derivatives, maxima and minima, limits, continuity, differentiability, maxima and minima, maxima and minima, Lagrange's method of multipliers, Jacobian. Jacobian and Raymond's definition of definite integrals, definite integrals, infinite and improper integrals, double and triple integrals, infinite and improper integrals, double and triple integrals, and its applications. Right, so this is the complete syllabus actually what we will be discussing as part of this calculus topic, right? So you can just read through this syllabus, you will understand what exactly is going to be there, right? See this, so real numbers and functions of real variables. So all these things actually very, very base level. So if you notice, so functions of 2 or 3 variables is there, right? So this is actually just the repetition of the same thing, whatever we are going to discuss it here for a single variable. Now for the single variable, actually we take just a variable x, which is an independent variable, and for which we will take the function, and for that function the existence of the limit and continuity and differentiability, we are going to check it. And this actually we will be discussing as part of that. And a single independent variable function, we will take it and we will try to find out the maxima and minima. And all these things actually, so +2 standard or intermediate standard syllabus, this everything, whatever I have drawn until this particular point is actually the intermediate level syllabus, right? Everything, whatever we have learned as part of intermediate, that is as it is repeated here. You don't need to study anything extra because this is only the fundamental part. And this is actually the extension of this. So when there are more than one variable, so we talk about the partial differentiation, we go a bit deeper in that, and the partial differentiation, and then with multiple variables, how to find out the limits, continuity, differentiability, maxima and minima. So, and for finding out the maxima and minima, we use, there is a method called Lagrange's method of multipliers. So all these things actually we'll be discussing as part of this. And there is something called Jacobian, which is the application of the differentiation, which I have already discussed to find out the integral. And then actually Riemann's definition of definite integrals, infinite and improper integrals. So this portion actually we will be covering as part of the real analysis. So there also I myself will be taking up. So real analysis, hence actually, so all these things I will be discussing as part of the real analysis because that is discussed over there more, right? Real analysis. And so double integrals and triple integrals actually we will be discussing in calculus itself. This double and triple integrals, its applications for finding out the areas, volumes, right? Surface areas. So those are all the only parts actually we'll be studying. This is actually very simple and short syllabus. So though actually, so to write the entire syllabus actually it is one complete board actually it has taken, but in reality actually it won't take that much time because I assume that actually you did well at +2 standard. Now in that case actually why do I need to rediscuss everything again and again, the same thing? But that doesn't mean that actually I won't be covering it. I'll be covering everything with very, very fundamental level. But actually it won't take much time because actually you will be able to cope up immediately. So if you people take time to understand, then actually it takes time for me. But otherwise actually it will be very easy, right? So this is everything actually we'll be covering it entirely. And what is important is calculus you look at from the perspective of dependency of this topic to others. So don't just actually go with the UPSC questions. So because actually maybe certain areas actually UPSC questions are focused, but the knowledge what we are going to acquire is of no use. So actually it's not a waste. So this knowledge, so each and every point in this particular board is applicable in other topics. So that's why actually try to understand the topic as it is. So irrespective of what are the questions actually that we expect from this particular sections. Right. So to talk about the questions, actually mostly I feel that actually, so this is double and triple integrals applications, especially to calculate the surface area. So this is one particular place actually we can expect the questions. And another is actually the mean value theorems with reminders. So that is one particular section actually where UPSC is asking the questions, right? So, and continuity and differentiability of multivariables, that is two variables actually, that also actually sometimes it is asked. So continuity and differentiability of two variables, and double and triple integrals application for finding out the surface areas and the volumes, right? And so in this case actually maxima and minima with Lagrange's method of multipliers. So this is also one section actually most of the times the questions were asked. So these are all the only important areas, and other areas of importance is actually the curve tracing. I think the curve tracing, yeah, curve tracing is there, right? So asymptotes and curve tracing, this is also one section actually where you can expect the questions. Got it? Right, so this is the syllabus and these are all the important areas of focus, but nevertheless you focus everything on this particular topic. Got it? Any questions on this syllabus you can ask me now. Any questions? Right, okay. And the next thing is actually, so I have answered, so what is the syllabus, and then I have answered what is the weightage of this particular topic and what are the books to follow. So especially, so BS Gravel actually it is meant for the engineering mathematics, BS Gravel. So all these applications are actually, so calculus actually is more of application oriented subject. So that's why actually calculus BS Gravel actually is very good book, but only for the integral calculus, not for the differential calculus. So differential calculus, though it was discussed, there are certain areas actually which was not discussed there. So especially like curve tracing, asymptotes, and these concepts not widely discussed. There were certain areas actually where it was discussed, but actually BS gravel is not 100% sufficient, but it covers around 70%. So BS gravel, and it covers actually 70%, right? 70%. Remaining 30% actually, so differential calculus, Krishna series. Right, Krishna series. So these two books actually will cover all the syllabus, right? Krishna series. So these two books actually you need to have it. And anyway, actually from both of these books actually we have prepared the material. So our material will cover everything, right? So that is good enough. But actually it will be always advantageous to carry the textbook, because actually there are so material actually precisely we will give whatever is expected by UPSC. But if you have some fundamental conceptual doubts, then it is always better to go back and look at the textbook. So that will be easy. Material is an extract from there, where actually it will be easy to prepare for UPSC. But fundamental knowledge you can get it from the textbook, right? So that you have to keep it in mind. And this is, two books are good enough. So it will cover 100%, right? No other book is required. And then actually, what is the weightage of, so what are the important areas of focus? This also I have discussed. And then actually approximate number of hours for this particular topic. So this is actually too many concepts within a short syllabus. So that's actually, it takes a bit of time. So I think around 30 hours actually I will take it. Approximately 30 hours I will take. So approximately, right? And then actually, so previous year questions actually I will show it, so that actually we will get to know what is expected from this particular topic, right? Now, let us see what it is, right? So this actually, you can see the questions from this particular one. Now we'll go back to 2019 and then come back. Right, so this is actually 2019 paper, and you can see the questions and see this. So let f from 0 to pi by 2 and r be a continuous function such that f of x is equal to cos square x by 4x square minus pi square, where 0 less than or equal to x less than pi by 2. Find the value of f of pi by 2, right? So this is a continuous function. Actually, he asks us to find out the value of f of pi by 2 based on this particular condition. So this is actually, most likely this is the real analysis question, but that's okay, we can solve it here. And then actually, so let f from d to r be a function and a comma b, right? A comma b belongs to d. If f of x is a continuous at a comma b, then show that the functions f of x comma b and f of a comma y are continuous at x is equal to a and y is equal to b respectively. So this is actually related to the continuity and differentiability. So this continuity concept we will discuss clearly. So this one, right? And then, so this is f of x is equal to mod of cos x plus mod of sin x differentiable at x is equal to pi by 2? If yes, then find its derivative at x is equal to pi by 2. If no, then give the proof of it. So this is actually a question related to, again, the differentiability. So continuity and differentiability is more focused, so that you have to understand. Find the maximum and minimum value of the function f of x is equal to 2x cube minus 9x square plus 12x plus 6 on the interval 2, 3. So this is actually directly an example problem from BS Gravel, finding out the maximum and minimum with two variables. So this is a single variable function, yeah, right? And then actually, if u is equal to sin inverse of x power 1 by 3 plus y power 1 by 3 divided by x power 1 by 2 plus y power 1 by 2, then show that sin square u is a homogeneous function of x and y of degree minus 1 by 6, and hence show that x square dou square y by dou x square 2x in y into dou square u by dou x dou y square into dou square u by dou y square is equal to tan u by 12 into 13 by 12 times plus tan square u by 12. So this is a BS Gravel standard textbook where this was discussed as an example problem, right? So this is also from BS Gravel only. Using the Jacobian method, show that if f dash of x is equal to 1 by 1 plus x square and f of 0 is equal to 0, then f of x plus f of y is equal to f of x plus y divided by 1 minus xy. So this is actually, you can notice that actually this is a tan inverse x function, and this is tan x plus tan y divided by 1 minus tan x into tan y is equal to tan x plus y, where f of x plus y is equal to f of x plus f of y, right? So this is actually a special kind of function actually. So this actually we will be discussing, right? And these are all the questions. . right? Determine the limit z tends to 1, right? 1 minus z tan pi z by 2 exists or not. If the limit exists, then find its value. So this is actually the complex analysis technique, right? So it's not the real analysis. So it's not the calculus. So this is complex analysis question. And this is find the limit n tends to infinity 1 by n square, sigma r equal to 0 to n minus 1, n square minus r square. So this is actually, he asks us to find out the limit value. That is one thing. Or else actually this can be called as, so the integration technique actually we can use. Integration as a limit sum, we can use it, right? So this is again the calculus bit only. And find the shortest distance from the point 1, 0 to the parabola y square is equal to 4x. So this is actually finding the maxima and minima, and that actually, so that application we can do for finding out the minimum distance for this. And the ellipse x square by a square plus y square by b square equal to 1 revolves about the x-axis. Find the volume of the solid of the revolution. So this is actually, so volume of the revolution, right? So this is actually a technique where if the area is getting rotated about an axis, then it is going to generate the volume. The volume generation, there is a formula, which is the application of the double integrals. So that actually we will be doing it in this particular case. And find the shortest distance between the lines a1x plus b1y plus c1z plus d1 equal to 0, a2x plus b2y plus c2z plus d2 equal to 0, and the z-axis. So two different equations, plane equations were given, and then actually z-axis was given, and he asked us to find out the shortest distance between them. So this is actually the solid geometry question. It's not the calculus question, but that's okay. You can apply. And let f of x comma y is equal to xy square if y greater than 0, and minus xy square if y less than or equal to 0. Determine which of dou f by dou x at 0, 1 and dou f by dou y at 0, 1 exists and which does not exist, right? Out of this actually, which one exists, which doesn't exist, the partial derivative. So this is actually two variable existence of the differentiability and limits continuity. So that concept actually we will be discussing in that we can solve this question. And find the maximum and minimum value of x power 4 minus 5x square plus 4 on the interval 2, 3, right? So this is actually the maximum and minimum technique. So this is a simple question, straightforward. And evaluate the integral 0 to a x by a to x dy by dx divided by x square plus y square. This is very, very simple question. So finding out the double integral straight away. See, in 2017, right? So this is actually integrate the function f of xy is equal to xy into x square plus y square over the domain. So the domain was given minus 3 less than or equal to x square minus y square less than or equal to 3, and 1 less than or equal to xy less than or equal to 4. And this is the domain actually he has given, and he asked us to find out the integral of this particular function over this particular region. So this actually specifies certain area where you have to do the integration. And find the volume of the solid above the xy plane and directly below the portion of the elliptic paraboloid x square plus y square by 4 equal to z, which is cut off by the plane z is equal to 9. So this is actually the application of the integrals, multiple integrals to find out the volume. So that is actually a straightforward question. And this is if f of x comma y is equal to xy into x square minus y square divided by x square plus y square, and x comma y not equal to 0, and the function value is 0 if x comma y is 0. Then calculate dou square f by dou x dou y and dou square f by dou y dou x at 0, 0. So this is very simple question, multivariable calculus, this one, right? Very simple question, straightforward. And this is actually examine if the improper integral 0 to 3 2x dx divided by 1 minus x square 2 by 3 exists. I think it's not an improper integral. So this is actually anyway, so I think so this is actually integral actually we need to be solving for this. Prove that pi by 3 less than or equal to double integral over the domain dx divided by x square plus y minus 2 whole square is less than or equal to pi, where d is the unit disk, right? So this integral value actually we have to prove that this is going to be in between. So this is actually the real analysis concept here. So that's it. So these are all the questions, but if you notice, what is happening is we will see this 2016 also. Evaluate integral 0 to 1 cube root of x log 1 by x dx, right? So this is x log 1 by x dx. So this is an improper integral. So where the functional value is coming out to be infinite at one particular location, then it can be called as an improper integral. So this improper integral we need to be solving it. And find the maximum and minimum values of x square plus y square plus z square subjected to the conditions x square by 4 plus y square by 5 plus z square by 25 equal to 1 and x plus y minus z equal to 0, right? So this is actually Lagrange's method of multipliers. That is the technique, which is a standard technique, which will be used to find out the maximum value when there are two different conditions here. So that is the application of it. Actually, it was given. And let f of x comma y is equal to 2x power 4y minus 5x square y square plus y power 5 divided by x square plus y square whole square is the value if x comma y is not equal to 0 and the function value is 0 if x comma y equal to 0, and find a delta greater than 0 such that mod of f of x comma y minus f of 0 comma 0 less than 0.01 whenever x square plus y square is less than delta. So this can be even be solved with the complex analysis technique also, but this actually it was given in calculus. And find the surface area of the plane x plus 2y plus 2z equal to 12, cut off by x is equal to 0, y is equal to 0, and x square plus y square equal to 16. So this is actually the application of the surface integrals, right? And then actually, so evaluate integral f of x comma y dx dy over the rectangle r equal to 0 comma 1, 0 comma 1, where f of x comma y is equal to x plus y, and if x square less than y less than 2x square, and 0 elsewhere. Right, so this is actually the question. So if you notice, actually most of the times actually one is the maxima and minima, another is the improper integrals, and another is the multivariable calculus, finding out the continuity and the differentiability within the specified range. So these are all the summary of all the questions actually what is expected by UPSC. Got it? So if you notice, all the questions are repeated with the same concept. One is the Lagrange's method of multipliers. Right? So I'll just actually summarize it. So one is the questions that are expected is multivariable calculus, and the second one is Lagrange's method of multiplier, Lagrange's method of multipliers, and even maxima and minima also it was asked multiple times. Maxima and minima. And the third one is improper integrals. And the fourth one is surface area volume calculations. Right, volume, surface area and volume calculation. And I think these are all the only 4 sections actually you can notice most of the questions. So these things actually you need to be focusing it to get maximum out of it. So all these 4 points actually I will give just because of the reason that with lesser effort, if you wanted to get more score, then these are all the things that you need to focus. So you don't need to be worrying about the entire syllabus. These things actually will give you most of the score. So because these are actually repetitive in nature. So almost all the concepts actually UPSC will be repeatedly giving again and again the same concepts, right? So that is the usual case. So that's actually with lesser effort, if you want to get it, then you focus on this. But calculus as a topic, I suggest to study everything appropriately. Got it? Any questions? Right? Okay. So that's all for today. Yeah, thank you. So tomorrow.